starting our lesson today by going quickly over what we learned yesterday about the parent of all functions, so the parent of all quadratic functions. Okay, what are the things that we've learned about that? And then we're going to look at transformation from that parent function. Okay, so what's the parent function of quadratic? Y equal x squared. Yeah. Okay? That is the parent function. And what did we learn about the parent function? Where does the vertex happen? At 0, 0. That's right. The vertex is at the origin. And then we said the axis of symmetry is at x equals 0. We said that the optimal value is at y equals 0, right? So that origin point was the important point, right? That's the point of the parent function. Now, what was the step pattern yesterday for the vertex? 1, 3, 5. Okay? So the step pattern is going up 1 over 1, go up 3 over 1, go up 5 over 1. Okay? And we said that this is the pattern that we're going to see when it comes to quadratic, okay? But there might be some changes depending on the a value. Okay? So today we're going to look at what happens to the graph because, I mean, not all quadratic, right? Not all quadratic functions look just y equals x squared, right? We have different kinds of equations. So it could be y equal squared plus 3. Don't write this, okay? Or it could be y equal 2x minus 1 squared plus 5, right? Or it could be y equal negative a half x squared plus 3. So you see that these are all quadratic functions because they all have a square, right? But they're not the same as my parent functions, which is y equals x squared. So we're going to look at what happens to the graph, to the function, as I add and subtract and multiply things to the x squared. Okay? That's what we're going to focus on today. All right? So the first thing that we're going to explore today is, what if I have something multiplied by the x squared? Okay? We call that something the letter a. Could be a could be 5, could be 10, could be minus 3, could be minus a half, plus 3/4, could be any number. Okay? So we're looking at functions that look like this, where you have y equals something x squared. Okay? So the first function, which is the parent function, is y equals x squared. We compare everything to the parent function. So we compare everything to the parent function. Okay? So y equals x squared. Then what happens if I have y equal 2x squared? What happens if y equals 0.5x squared? Y equals negative 2x squared? And y equals negative 0.5x squared. Okay? Now, my question to you, y equals x squared, which way did it open yesterday when we graphed it? Which way was the opening? It was opening up, right? It looked like this, right? With the vertex at 0, 0. Okay? All right. So we're going to get Desmos, and then we're going to graph them, and then we're going to see what's happening to the graph as I am including a number in front of the x. So always I have functions so I can compare things to it. Okay? So this looks like what we graphed yesterday. Yeah. Right? So this is my vertex. It's at 0, 0. And then if I have 2, it would be 4. Right? You see these points. And then if I have 3, it's going to be 9. Okay? So this is my original function. My original parent function. Now, I'm going to graph y equals 2x squared. equals to x squared. Comparing it to y equals x squared, what can you tell me? It's narrower. Okay, I don't want to use that word yet. Okay, just because it depends on which way you're looking at it. Okay, but you, like, I know what you're trying to say. Okay, so you said narrower. Okay, does it still have the same vertex? Yeah, it's still at 0, 0. How about the y, the axis of symmetry? Still the same. Minimum value or maximum value? Still the same. Is it still the same direction of opening, still opening up? Exactly the same, right? The only thing is that it's narrow. Okay? Now, what happened if I have y equals, what was it, half x squared? So if you look at the green graph, always compare to the original. So always you're comparing to the red. What can you tell me about the green graph with respect to the red graph? It's wider, right? It's a wider graph. Okay, you see that? The green one is wider than the red. The vertex did not change. The axis of symmetry did not change. The direction of opening did not change. Okay, it's just wider. Now, 2x squared made it narrower. 0.5x squared made it wider. Give me another value of a that's greater than 1. 5. So if I have y equals 5x squared. Look at this. It's the purple one. What do you notice? It's even narrower. Right? Right? If I do y equals 6x squared, right? It's going to also be narrower. Okay? So the bigger the a value, the narrower the graph. Okay? Now, I'm just going to delete these, and I'm going to look at values that are below 1. So between 0 and 1. Give me values between 0 and 1, other than 0.5.
0.2.
Okay, so 0.2x squared. What is it? Even wider, right? Wider, right? So if the number is greater than 1, what's happening? It's narrower. And if the number is between 0 and 1, what's happening? It's wider. Okay? Now here's something that I want to show you. We're only going to talk about vertical here. Okay? So we're going to look at vertical. Does anyone have an elastic? Okay, think about an elastic. If you want to make that elastic narrower, what do you do with it? Okay, so this is your quadratic. Okay, this is your original. I'm not even doing anything to it. And I just want to work with vertical. Okay, I just want to work either up or down. If I want to make this narrower, what do I do? What do we call that word? What's that word called? Vertically stretch it, right? And then if I vertically stretch it, it becomes narrower. Do you see that?
Yes.
Okay, so it's like this. If I vertically stretch it, it becomes narrower. Okay? Now, what if I want to make it wider? What do I do?
Compress.
Vertically
Compress.
compress it, right? Compress means you press on it, right? So you're vertically compressing it. So these are the terminologies that you have to use when you're describing wider and narrower. We don't use the words wider and narrower. You have to remember, in order for me to make this narrow, I have to vertically stretch it. Okay? In order for me to make this wider, I have to vertically compress it. Okay, we're gonna write that. But remember that no matter what, your vertex is still the same, right? So my vertex is not changing. So that number that's in front of the x squared is not affecting my vertex. It's just affecting my wideness, right? The wideness of the graph. Now, if you're going to look at the step pattern, do you think the step pattern is going to be affected by this? Am I still going up 1 over 1? Up 3 over 1? Am I still going that? No. So this is what's going to affect the step pattern. This number here, the A value, is going to affect the step pattern. Okay? And that's, if you remember yesterday, I said it's A times 135. And I used the letter A for a reason, right? Because I want to connect it back to this thing. Okay, we'll talk more about this. Okay? Now, let's describe this. The value of A for this one is 2. The direction of opening, up. The vertex,
0,
0, 0.
0, 0.
The axis of symmetry did not change. It's x equals 0, right? So if we go back here, right, the axis of symmetry is still the same. It's x equals 0, right? It did not change. Okay? Now, we're going to compare the shape. So we're going to say that for the 2, it was vertically stretched. So we have a vertical stretch. Okay? I'm going to put in bracket, it's narrow, but you don't write this, okay? So when you're describing the transformation, you don't write narrow. It's just for you to know that when I'm looking at vertical stretch, just for you to picture. Okay? All right. Now, what's the A value for C? 0.5. Direction of opening? Up. Vertex? Axis of symmetry? X equals 0. And then it's a vertical compression. Okay, now the other two examples are y equal negative 2x squared and y equal negative a half x squared. How do you think this is going to affect my graph? It's going to flip. Yes, it will. It's going to start opening down. Look at this. Because now instead of going up 1 over 1, up 3 over 1, it's going to start going down 1 over 1, right? Because remember, negative means down. Okay? So I'm just going to delete these. And then this is the 2x squared, so the blue one is the 2x squared. Now if I change it to a negative 2x squared, you see what happened? Look. Okay, that's the original one. And then if I make the A value negative, it flips. So instead of opening up, it's going to start opening down. Okay? the axis of symmetry change? No. Okay? The only thing that changed, instead of having a minimum, now I have a maximum. You see, this is a maximum. Okay? I still have my vertical stretch. Okay? It's a vertical stretch and a deflection. We call that a deflection. Okay? So what's happening here is it reflected in the x-axis. Okay? We'll write that. Reflection. Mhm. And then look at this. Again, if I have 0.5 and now I have a negative 0.5, again, it's opening down. Okay? So, what's my a value for negative 2x squared? Negative 2. Direction of opening? Down. Vertex? 0, 0. Axis of symmetry? Okay. Now, for vertical stretch, I will be writing Vs. So that represents vertical stretch. For vertical compression, I'll be writing Vc. Okay? You can write this on the test as well. Okay, I will understand what you're saying. As long as you don't mess up your letters, because if you mess up by one letter, then I wouldn't know what you're trying to say. Okay? So vertical stretch is Vs, vertical compression Vc. Now, this one we said there is a vertical stretch, but also there is a reflection. So there's two things happening. There is a vertical stretch and there is a reflection in the x-axis. Okay? So when you're reporting a transformation to me, you're going to say vertical stretch and a reflection in the x-axis. I'm looking for both of these. For E, what's the A value? Direction of opening? Vertex? Axis of symmetry? And I have a vertical compression and a reflection in the x-axis. Yep.
Is it necessary to write in the x-axis?
Yes. Yep.
Like, can there be reflections in the y-axis?
Yes, there can. Okay? We don't learn it, but there is a reflection in the y-axis. Okay? Okay. Sign of A indicates what? So this, if A is positive or A is negative, what does it tell me?
The direction
Direction of
of
opening. Yeah. So the direction of when A is positive, the parabola opens up and has, if it opens up, then it has what? Max or min?
min.
Min. When A is negative, the parabola opens down and has a max. This is known as a reflection. Okay, so something to keep in mind if you can't remember. Negative which way does the N open? N opens down, right? Which way does the parabola open? Down. Right? N, it's a parabola opening down, right? So just if you can't remember which way does it open. So if it's negative, N opens down. value of A. Now, if it's negative, the only thing that negative tells me, which way does it open? It only tells me that it's opening down or opening up, right? After I take that and say, okay, negative, that means it opens down, I forget about the negative. I move on to the actual value of the A. Okay? So the value of A describes the,
Compression and
that's right, so it describes the shape of the graph. Okay? If A is between 0 and 1, the parabola is, did we say, is it wider or is it narrower? If it's between 0 and 1, it's wider.
Sorry, wider.
And known as a vertical compression. Okay? Wider, right? It's a vertical compression. If A is greater than 1, the parabola is narrower than y equals x squared, and it's known as a vertical stretch, narrower. Okay? Remember that the A value does not affect your vertex. We're going to look at what affects your vertex. So there's other things that are going to affect your vertex, and they're going to move things around. The A value is only going to affect if it's going to be narrower, wider, and the step pattern. We'll talk about that. Okay. So here's how we're going to learn how to graph these beautiful quadratic parabolas. All right. So my equation is y equal negative x squared. So what kind of transformation? We're going to have to list the transformations, and then we're going to have to sketch.
be reflection and compression.
So it's going to be a reflection in the x-axis. Do you agree with that? For the first one, it's a reflection. Okay. And
Vertical stretch.
vertical stretch. What's the value of A? What's A? Negative 2. The negative is going to cause the reflection, right? Okay. And the 2 is going to cause it to do what? Vertical stretch. Okay. So we have a reflection. So when I ask you to state the transformation, you're going to have to say the following. Transform. You're going to say reflection in the x-axis, and you're going to say it's a vertical stretch. Okay. Now we need to sketch. Okay? Anytime you're sketching quadratic, you want to start with your vertex. Okay? So we're going to list our features here. What's the vertex? 0, 0. Because remember, this is not going to affect my vertex. The vertex is going to stay at 0, 0. Okay? Now, step pattern for the regular y equals x squared is what? 1, 3, 5. Okay? But because I have a vertical stretch and a reflection, my step pattern is not going to be 1, 3, 5 anymore. It's going to be multiplied by the A value. Okay? So your step pattern is A times 135. Okay? What's my A value? So it's going to be negative 2 times 135. And that's going to be negative 2, negative 6, negative 10. Okay? So my step pattern is negative 2, negative 6, negative 10. Let's see how that's going to work. So you see, I'm making sure that I'm going down by 1. Okay? If I want to use the step pattern, I have to make sure that I'm going down by, like if you look at my y-axis, it's 1, 2, 3, 4, 5, right? So each square or each whatever that small line, it's a 1. Okay, can you guys just pay attention to this and then I'll give you time to graph it? Okay. My vertex is at 0, 0. I have to locate that vertex first. Okay? So I'm going to locate the vertex. And then I'm going to have to use the step pattern to find my next point. The step pattern says go down 2, because it's negative, over 1. It's also over 1. Okay? So I'm going to go down 1, 2, and over 1. So I'm going to be at this point right here. Okay? So down 1, 2, over 1. Okay? Now, from this point, I have to go down 6 now. Okay? So, from this point, I have to count 6. So 1, 2, 3, 4, 5, 6 over 1. Okay? From this point, I have to count how many down? 10. Right? Because you see this? Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 1. Of course, when you have a grid, it's easier for you to graph, right? Because you already have the squares. All right? So you see this is my right side. Okay? I have to do exactly the same thing on the left side. Okay? So I'm going to go down 2 over 1, down 6 over 1. So you see the points. I'll show you 1 second. You see that your points are going to be at the same y value, right? To the right or to the left, they're going to be on the same y value. Okay? Are we okay with this? So you start at your vertex, and then you do your transformation. You do your step pattern. Okay? So take some time to graph this, and then if you're done graphing this, I want you to list the transformation for us. And then if you can find the vertex and the step pattern.